In order to teach our hero to walk upstairs, we first have to talk about Agent Smith from The Matrix. Now, Agent Smith was a computer program, and the program had a level of artificial intelligence. The artificial intelligence is actually older than computers itself. It is a way for individual objects, or in this case, agents in AI terms, to make decisions for themselves on where to go and what to do when a certain situation arises. Like I said, the idea of artificial intelligence is older than computers. For example, heat-seeking missiles would turn left or right in response to the source of infrared light. In our case, we simply want our hero to walk in and out of the house and around the fence. To begin, open up the navigation menu. In your scene, change the view mode to wireframe. And now let's take a look at what we have. Now, when we select several of our objects, this is an empty game object with a child, we see that several of them are also already marked navigation static. You will also have the same, which is included in the file. Now, there are several places which we want our hero to go to and several places we want our hero to avoid. One of these places, for example, would be the door. Click on front door. The navigation is not marked static. It will not be mapped. Because of this, the navigation will be disregarded. So instead of talking about it, why don't we just create it? Go ahead and click on bake. Here we see this blue floor that is generated. These are all the areas that our hero can walk upon. We see that the fence is avoided, and same for the trees. He can walk on top of the roof. We'll leave it as is for now, but we could uncheck it if we like to. But let's not limit where a hero can go. We also see that he can walk inside this tunnel, but it is currently blocked by this bridge. Probably more of a curb. We go back to shaded mode and hit play. Nothing will happen. Our hero has no way to actually get to a destination. We'll have to script it in ourselves. The most obvious way to do it is basically create a way for us to click or tap to a certain area, and that's where our hero will get to. So let's create a script. In your code directory, go ahead and click on create, C# script, and I'm going to call this destination mover. Double click. Click save. Okay. Reload. And destination mover. Before we do anything else, the first thing that we want to assign is our way to tap or click on a certain location and have our hero locate to, or just retrieve a vector3 for the time being. So in the update for every frame, the way that we are going to retrieve that is we're going to be using the input class and the get mouse button method. And we're going to be specifying this as just button 0. Open up the braces. And now we're going to be defining a raycast, meaning a cast that is going to be a ray that is going to be cast from the camera. Maybe imagine if you have a camera taking a pencil and holding it from the lens. And wherever you point the pencil, that is going to be the point where a camera will hit. In our case, the pencil will be either the mouse click or the finger for mobile devices. So first of all, we're going to be creating a new point where the ray is going to be hit, which is a ray cast hit. And I usually like to keep this convention for defining variables. And now we're going to be creating a new ray camera.main. And then creating a screen point to ray position, which is where the screen point of where we clicked that is going to be launched. Think back to the pencil analogy. A point in the world where our camera has hit. Okay? You'll see, if I haven't explained myself clearly, you'll see this soon enough. Input that mouse position. Now don't worry, even though I'm specifying desktop terminology, this will be translated to touch commands. Okay, so we define the ray. Now we want to check in each frame whether that has been cast. So we'll check if physics.raycast. In the parameters, we're going to be specifying the ray, where it's going to land. You can see that we've got a variety of functions here. So hit info, the raycast hit, we can get a variety of information from the raycast hit. So out raycast hit, the distance that we want the ray to go for, and that's it for now. We're going to be coming back to this conditional in a little bit, but let's just keep things simple for now. So make sure to close all of your parentheses, open up, close the braces for the conditional, and let's just print this. Actually, I'm going to be sticking it to debug.log for now, just for the sake of this tutorial. Raycast hit dot point, and that's going to give us a vector3 position of where we clicked. Okay, let's go back to Unity and attach this onto our hero. Let's close the audio source. And destination mover. Okay, let's play. I'm going to be clicking on a point, and we are getting a null reference exception at line 11. Let's look at line 11. I'm referencing the main camera. I created this camera, maybe there's something wrong with it. And I see that under the tag, it is untagged. A camera, in order to be tagged as a main camera, needs to have a main camera tag. Let's try it again, and this should fix it. And we are getting this point. Obviously, our hero is not moving anywhere because we are not doing anything with the nav mesh. And in order to do so, we need to add a, remember the term agent? Nav mesh agent. Now that we've got that, we can access the class. Back to MonoDevelop. Let's assign a reference to the nav mesh agent class. Nav mesh agent. Nav mesh agent. Okay, I'm going to be using the start function in order to assign it. Start. Nav mesh agent equals get component nav mesh agent. Now that we have our nav mesh agent class, we don't have to just print this out. We can actually set the nav mesh agent to move to that point. It is extremely simple. Instead of just having the debug log, type in nav mesh agent dot destination, and then keep everything that we have. Maybe move up the parentheses. Click Save. Go back to Unity. Okay. And let's click to a point. And our hero is moving to that point. There's no animation because we have not assigned any animation to it. But for example, if I hit to a point of where that is outside of the point, he will get to it. He goes up the stairs. Well, would you see something that our hero is getting from the inside of a fence? We can probably, maybe you do want that. I don't want that actually. It seems to be a tight squeeze. I would rather not him go there. So in order to fix these things, in order to fine-tune it, we need to increase the size of the radius of the agent within the nav mesh itself. So let's go back into the bake settings, and we have some settings up here. These are brand new to Unity 5. This is this UI. Now, in order to get not such a tight squeeze, I'm going to fatten up our agent. We're immediately getting an alert here that says that considering the width of the agent, the slope that we're using has to be lower. So in this case, the problem is that the hero needs to take bigger steps in order to reach this height or lower this height. So we are going to increase the step height to 0.5. And let's rebake. So the effect that I wanted was successful. As you can see, the blue path that is going to be the navigation mesh no longer goes around the actual bridge, but we are still able to get in the house. If we can see that we are going past the door, we are able to get in. If we go up here and walk on the stairs, and then go outside of the fence, our hero will have to completely walk around. Good enough? Let's animate him. I'm going to create a new script. I'll be calling it Animation Manager. Open this up, create an instance of the animator class, and the start, let's assign it to the animator. Animator equals, and let's create a public method to start the walking cycle. So public void, and I'm going to be calling this walking with a parameter passed on as to how much we actually want the walking float within our animator to be affected. So float walking, okay? Now, and once again, this is not a class on Mechanim, so you'll just have to kind of blindly follow instructions if you're not familiar. We are going to set a float within the animator, and we have two parameters here, either ID or string name, and the value. So our string name is going to be walking, specifying a string, and then the value is going to be walking. Okay, that's going to be just passed on from the method. Save that, back to Unity, let's drop that script on. Village Man, component, animation manager. Now let's go back to our destination mover, and now we're going to be creating an instance of the animation manager. So animation manager, manager, there it is, animation manager, assign it, animation manager, equals get component, animation manager, animation manager. So upon the actual mouse hit, we want something to happen. We want our hero to start walking up until that point. But how much do we want that float to be set to? Let's put a bookmark here and test something out. In here, I'm going to be creating, create a log in the console, and I'm going to be using a function that I'm going to be showing, which is called the agent velocity. So let's just give us a hint. I'm going to usually like to type in all caps so it stands apart from everything else. And that's how we make a log in the console. We're going to be typing in navmesh agent, dot velocity. Okay, and let's go back to Unity. Okay, that's fine. We're not setting any animations manager, so it's telling us that it's not using. We will soon. Okay, let's Okay, I can move this. Okay, I'll keep this high. Yeah, I can't lower it. Fair enough, Unity. Mercy. Alright, so let's click Command P. What I'm interested here most is the console. Let's at least give me some more room on the console. Right away we're seeing that the agent velocity keeps giving me just 0, 0, 0. That's right, because our hero is standing in place. Okay, and let's move him to a different point. And something that I'm interested in is the z value, that is how much he's moving in front of him. And we see that it's the further we put, the further our hero moves. If we move something to very close to him, of course the velocity will be lower. So in this case, I simply want the hero's highest velocity to determine how fast he is walking. Keep in mind, we're addressing the z value, just what's in front of our hero. Okay. Let's create another function to assign this. Just name it walk. In its parameters, I want a float value that is going to be the velocity. Okay, so we're going to be pulling this velocity from here and passing it on to this method. Now we want to access our animation manager class, so animation manager. No thanks. Animation manager dot walking, and pass on this parameter, which is going to be velocity. Now we're going to be figuring out what this velocity is the same way as we did before. Float velocity. By the way, we've got several velocities here. That's all right, because we're defining this within the conditional statement, within the actual method. And we notice that the value can be positive or it can be negative. What we want is the absolute value. We want if it's going to get to 3 or to -3, we want to get it absolute. And for that, we're going to be using the absolute function that is built into Unity. It's within the Unity engine. So to do that, we type in mathf.absolute.abs. And now what I want is to access the navmesh agent.velocity. Now we notice that it goes up to 3.5 or something. Let's cap it at 3, and I'm going to be dividing this by 3. Okay, and now I'm going to be invoking the walk function and passing out velocity. Okay, this should be good. Let's go back into Unity. And we are getting an error. It says that the method match for absolute float has some invalid arguments, and then it gives us a little bit more detail. Cannot convert vector3 to float. I think I know exactly what's happening. Currently, we are getting a vector3, and it's expecting a float. So of course, we need the z, the forward direction of our agent. And there's one more thing that I'm going to do, and it's actually to take this script out and move this in the update directly without this conditional, because this is going to be triggered once on each mouse, and we want the continuous movement, the continuous velocity, the change in position of the hero to affect the float of the walking state. Okay, save. Console all clear, Command P. Let's take a long distance walk. And there, something short distance. Before we actually handle the jump, let's implement some physics.